Very good morning to all of you. Topic is sectional views of solids. Where we use the sectional view, just to mark, this is one object. I want to identify the object inside the object. Means I want to locate what is inside the object. Then I use one cutting plane. This is my cutting plane, and I cut the object. When I cut the object is divided into two parts, and I assume to remove the part in between the cutting plane and the observer, means this part, and the surface which is produced is called the section of the object. Just you mark. So what is the definition of a section? The surface produced by cutting the object by the section plane is called the section, and it is represented by the cutting lines. These are the cutting lines. The section is represented by the cutting lines, and this is my cutting plane. Cutting plane means in which plane I cut the object, and this is the symbol of cutting plane. Symbol of cutting plane, or we can say section plane. This one is thin line, this is thick line, this is thick line, and it is represented by AA dash. So what is a section plane or cutting plane? The imaginary plane which cut the object is called section plane or cutting plane. Which is my cutting plane or section plane. And these are the cutting lines. Just to mark this object, I want to identify here this object. I am the observer, I mark from this side. When I observe from this side, this object is not clearly visible to me. I want to identify the object. So, the cutting plane AA dash is used to cut the object. When the object cut, I am the observer. This is the cutting plane, and the entire object is divided into two parts, part 1 and part 2. And I remove the part 2, then what is produced? Means the surface which is produced is called the section. This is the section. This small circle with the cutting lines is called the section, and the small circle and the big circle is called sectional view. Sectional view means, just to mark, the projection of the section along with the remaining portion of the object is called a sectional view. Means when I remove this one, actually in this portion I mark the cutting mark, and when I project my section, I mark this cutting mark plus this extra part also. Then only I identify my object. Okay, this is the sectional view, and this cutting portion is called the section. So what are the various types of sectional view? There are 6 types of sectional view. One is sectional top view, sectional bottom view, sectional front view, sectional back side view, sectional left side view, and sectional right side view. Just you mark. What is sectional top view? It may be asked in the Viva, what is the difference between top view and sectional top view? This is the object. I mark. Top portion of the object I mark, that is called top view. But what is sectional top view? This is the cutting plane. The cutting plane cut the object. Cut the object parallel to the ground. Then the entire object is divided into two parts, upper part and lower part. I assume the portion in between the cutting plane and the observer, means top portion is removed. Then the surface which is produced in the part 2 is called the sectional top view. Same thing, if I remove the lower portion and I mark the cutting mark in the upper part, that is known as sectional bottom view. If I cut the object like this and I remove the portion in between the cutting plane and the observer, I mark the sectional front view. If I remove this portion, sectional backside view. If I cut the object like this and I remove this portion, that is sectional left side view. If I cut the object like this and I remove this right portion, that is known as sectional right side view. So these are the various types of sectional views. Then how we will draw the cutting lines? It has some characteristics. The first characteristic is hatching lines are uniformly spaced. Gap is uniform. The gap between two hatching lines is 2 mm. You may take 1 mm to 2 mm, but we will take 2 mm. And angle of inclination is 45 degree, means you have to tilt your drafter. Now it is your 0 degree, you tilt it to 45 degree. This is your 0 degree, you tilt it to 45 degree and draw the lines. And when you draw the line, 2H pencil is used. So these are the characteristics of hatching lines. Just to mark the hatching lines. Hatching lines means angle of inclination is 45 degree. The lines are uniformly spaced. Then 2H pencil is used and gap between two lines is 2 mm. Where the cutting lines are used, then you use the word section. Just to mark here, I also use the same thing. 2H pencil, gap is uniform, gap between two lines is 2 mm and angle of inclination is 45 degree with the horizontal. Question number 2. Question is, draw the sectional front view of a cylinder having 80 mm diameter and 110 mm axis. The solid is resting on the HP with one of its base and 60 mm in front of VP. The cutting plane cut the solid parallel to VP and 30 mm away from its axis. This is the question. Just to mark the cylinder. And what is the position of a cylinder? The cylinder is resting on the HP. This is base 1, this is base 2. The cylinder is resting on the HP. Just to mark. With one of its base. This one of its base. And it is 60 mm in front of VP, means always remember the axis of the solid is 60 mm in front of VP. Axis. The diameter of the base is 80 mm and the axis of the solid is 110 mm. This is the position. First we draw its projection. Means when you observe from the top, you mark only a circle, and you observe from the front, you mark a rectangle in case of cylinder. After that, second part of the question, the cutting plane, cut the cylinder. Cut the cylinder parallel to VP and 30 mm away from its axis, it cut the cylinder. Telling the cylinder is divided into two parts. Now you draw the sectional front view. How will draw? Just to mark. Since it is in first angle projection, I will draw that top view, means a circle below XY reference line, and I will draw a rectangle, means in front view above XY reference line. Come to your block number 2 now, and you draw XY reference line in the middle of the block number 2. XY reference line. Already you know you will use 2H pencil. And you take 50 mm left side gap and 50 mm right side gap. Draw the same arrowhead. And write down XY. Small x, small y. And you know very well in first angle projection, this is HP, means you will draw top view. This is VP, we will draw front view. You measure XY and mark its midpoint, that is the midpoint. Through the midpoint, you draw a perpendicular line and thin line, arbitrary line, above as well as below. As well as below. And you draw a circle. You mark the center point O, that is 60 mm from XY reference line, because it is 60 mm in front of AP. O is the center point. O is the center and radius is 40, because diameter of the cylinder is 80, radius is 40, you draw a circle. Because the top view of a cylinder is a circle. Draw a circle and divide the circle into 4 equal parts. First, 4 equal parts. This is your A, B, C, D. This is the top view. Now you draw the projection from point A upward, from point C upward, and you draw the rectangle whose measurement is 110 mm. This is 110 because axis is 110, right? This is all about the projection of the cylinder. Just you mark, it has 2 base, base 1 and base 2. Say this is your ABCD base, this is EFGH base. When I observe from the top, the 2 circles become 1 circle. So here write down E, F, G, H, and here A dash, B dash, comma D dash, and here C dash, E dash, F dash, comma H dash, here G dash, and 2 center points become 1 center point. So here write down O1, comma O2, and here write down O1 dash, here O2 dash. This is the projection. After that, the cutting plane cut the cylinder. Cutting plane cut the cylinder. Just mark. The cutting plane cut the cylinder. This is the center point. The cutting plane cut the cylinder 30 mm from its axis. 30 mm from its axis. It cut it. So I will draw here the cutting plane. Means O1 to M I will mark 30, 1 point, and I will draw here the cutting plane line, 2 mm gap and 10 mm line, 2 mm gap and 10 mm line, and here I down AA dash. AA dash is the cutting plane which cut the cylinder 30 mm from its axis. Then here no material, then erase and use your 1H pencil, very thin line you draw for your reference only, but no material is here, and it cuts. Just to mark, when it cuts, and I observe from the top what happened. 1, 2, 3, 4 points it cut the cylinder. So I mark here, this is 1 point, 2, 3 and 4. This is the sectional top view. Then I will draw the sectional front view. How I will draw? Just to draw the projection from point 2 upward. From point 1 upward. From point 1 upward. And here you write down, this is 1 dash, this is 2 dash, this is 3 dash, this is 4 dash. So 1 dash, 2 dash, 3 dash, 4 dash is the sectional front view, which will mark the cutting line in that area. So first you dark this one. Then also dark this 1 dash, 2 dash, 3 dash, 4 dash area. So in that area 1 dash, 2 dash, 3 dash, 4 dash, you draw the hatching lines. Just to mark. How will draw the hatching line? Pencil change towards pencil. And tilt your drafter from 0 degree to 45 degree, either clockwise or anti-clockwise. And you mark here 2 mm, 2 mm, 2 mm, you mark here with the help of your scale. 2 mm, 2 mm, 2 mm, you mark. Right? And draw the hatching lines. Angle of inclination is 45 degree and gap is uniform, approximately 2 mm. You draw the hatching lines. Just you mark. Again you mark here 2 mm, 2 mm here, 2 mm, 2 mm, 2 mm, and through that point you draw the hatching line. So 1 dash, 2 dash, 3 dash, 4 dash is the sectional front view of the cylinder. Then in a capsule box write down the dimension. From the top 30, right side 30, width of the box is 30, each block is 6 mm, 6 mm, 6 mm, 6 mm to draw. First you write down AC, AC 80, that is the diameter, O1M, O1M 30, then E dash, A dash, A dash, E dash 110, this much only. And here one more dimension, that is A to E dash is 60, A to E dash, AE dash is 60, because this is 60 mm in front of, means A to E dash is 60. Question number 3, you will write in your copy. Draw the sectional top view of a cone having 80 mm diameter and 110 mm axis. The solid is resting on the HP with its base and 60 mm in front of VP. The cutting plane cuts the solid parallel to HP and 50 mm away from its vertex. This is the question. Just to mark. This is the cone. Base is 80 mm and axis is 110 mm. And the position of the cone is resting on the HP with its base. This is the position of the cone. And it is 60 mm in front of VP, means axis of the cone is 60 mm in front of VP. So the object lies in the first quadrant. Then the cutting plane cut the cone parallel to HP and 50 mm away from its vertex. From the vertex you measure 50 mm and cut the cone and remove the upper portion. And what you observe in top, you draw it. That is known as top view, or we can say sectional top view of the cone. Just to mark, after cutting, the cone becomes a conical frustum. Upper part is removed, it becomes a conical frustum. And when I observe from the top, what I observe? I observe small circle plus big circle in top view. Two concentric circles. And in front view, what I observe? I will mark, it becomes a straight line. It becomes a straight line, simply you join. Means it is a trapezium. You will draw. Come to the block number 3. In your block number 3 also you have the title box. In the middle of the block number 3, you draw XY reference line. XY reference line. Left side gap you take 20 mm, length of XY you take 120 mm and draw the same arrowhead you draw and write down XY. Length of XY is 160 mm and you mark the midpoint of XY 60 60 60 60 and draw the very thin line to the midpoint. Above as well as below. And you know very well, since this is first angle projection, I will draw top view below XY reference line and front view above XY reference line. You mark the point O. O to XY is 60 mm. And O is the center, radius is 40, you draw the first circle because diameter of the base of the cone is 80 mm. You draw the circle whose radius is 40. Radius is 40, you draw the circle. Then you divide the circle into 4 equal parts. This is the center point O and write down here A, B, C, D. This is the top view. Then come to front view, you draw the projection from point A, from point C, and you mark the point O dash, that is the vertex of the cone. How much? This XY reference line to O dash is 110. And simply you join. This is your A dash, C dash, this point is B dash comma D dash. You join O dash to A dash. You join similarly here also you join. Then you mark the point M dash because M dash to O dash is 50 and the cutting plane cut the cone. So here you draw the parallel line parallel to XY reference line, then 2 mm gap, 2 mm gap, then 10 mm line, 10 mm line. This is your AA dash cutting plane, AA dash cutting plane, cut the cone 50 mm from its vertex. Say it cut the cone, point say 1 dash and 2 dash. Now from point 1 dash you draw the projection because we need the sectional top view. So from point 2 dash you draw the projection downward. From point 1 dash you draw the projection downward. Now O is the center. This is your 2 points A. This is 1. O is the center. O1 is the radius. Draw another circle. Because in top view I already told you, you mark 2 concentric circles. And you draw the hatching line in the small circle. Same procedure you follow. 2H pencil. Here you mark 2 mm, 2 mm, 2 mm. Tilt your drafter to 45 degree and draw the hatching lines. This is all about the sectional top view. And here you dark this portion. And here you draw the axis line 6 mm, gap is 2 mm, then 2 mm line, gap is 2 mm, then 6 mm, gap is 2 mm. Accordingly you draw the axis line. Here you don't draw because no material is here, already it is removed. Then in a caption box write down the dimensions. From the top 30 mm. And from right side you take 150 mm gap because right side is the title box. And width of the caption box is 30 mm. Each block is 6 mm. First block 6 mm, second block 6, again 6, 6. So here write down with the help of your HB pencil AC. AC means diameter of the cone, that is 80, and O dash B dash at the axis, O dash B dash 110. Then M2, that is your, this is your M dash, this is your O. O to B dash, O to B dash is how much in front of? 60. Then O dash to M dash, O dash to M dash is 50 because from the vertex you measure 50 mm and cut it with the help of a cutting blade. Now the cone becomes a conical frustum. This is all about the sheet number 3. Thank you.